Hello everyone. Our next talk is going to be on comparing malicious files, brought to you by Robert Simmons. Enjoy.
Hello everybody. My name is Rob Simmons. I go by the handle Utkanos. I think some of you might know it, but it's, the word means duckbill platypus. Don't ask me why. So today I'm going to be talking about how to compare malicious files. And just a little bit about myself. I am now an independent malware researcher. I'm formerly the Director of Research Innovation at Threat Connect. So formerly, as of a couple weeks ago. And I want to start with going over some of the problems that I not necessarily have any solutions for them, but I want to identify some of the problems with comparing files and sample nomenclature, malware family nomenclature. So, and I apologize, I'm getting over a little cough. So the first problem is the antivirus problem. So antivirus companies, many antivirus companies have their own unique nomenclature for malware and malware families. So if you submit a file that's suspicious or unknown to an AV bank or to a specific AV scanner, you may get a result back. And that result may not actually be what the malware is, but it's the goal of AV is to detect and stop. It's not necessarily to identify, but this causes a lot of confusion because there's a lot of different names that something can come back as the results. There's another sort of subset of this problem, and it's the panda. So this is the marketing problem. So underneath the AV problem, you have the nomenclature problem where a company has a marketing team and dogs will hunt. The marketing team is doing their job, but what they want to do is name the things that you've discovered. So let's say you find a new malware family or a new variant of a malware family or something completely new, and then the marketing department hears about it. They hear you talking about it, or you send them a message about it, and then they want to name it. They want to come up with some fancy name for it. I think we all know one example of this. How many different names can one malware family have? APT28, Pawnstorm, Fancy Bear, Sednit, Zarteam, TG4127, Group 4127, Strontium, Tag 00700, Swallowtail, Iron Twilight, Group 74. Goes on and on and on and on. And so, and just to go back, you've got the problem of the pandas and the rocket kittens, and I'm not calling out one company specifically, but it's a problem with all marketing departments. You come up with something new, and the same problem exists in exploit and vulnerabilities. And if you find some flashbang new vulnerability, the marketing department wants to put a label on it and give it a logo and all that sort of stuff. So in the malware research area, this creates a problem because there are so many names for one single malware family or groups of malware family or related malware families. Those are more of the problems with the nomenclature. And then another part of my talk is about identifying additional samples. So not only do you need to figure out what a specific sample is, so what malware family it belongs to, but you also need to figure out what other files, what other samples are related to the file that you're looking at. And there are different reasons for doing this. So you have the malware researcher, and the malware researcher wants to know what he or she is looking at. They might have a sample, but a malware researcher is not necessarily in an emergency situation. They typically have enough time to sit down and think about what they're looking at. And one of the things they need to do is to relate the sample that they're looking at to additional samples related in different ways, so that they can potentially identify that through previous identifications of older files or older samples. And then, one of the things you really want to figure out is this something unique? Is this something new? Is this something that no one has seen before? Something that you haven't encountered before? Now, there's another problem that's very closely related to the malware researcher's problem, but this one is more an emergency situation. So you have the incident responder. So if you're on an IR team and you have a sample that you've collected off of a server or a sample that you've collected off of a laptop or a workstation, you're under the gun. You need to figure out exactly what this is, what it's done, reverse engineer it, and you need to do some of the same things that a malware researcher does, but you need to do it quickly, and you need to do it for a different reason. One of the main reasons is, can I find related malware that some researcher or another organization has already done work on, and I can, kind of take a shortcut to, my destination of figuring out what it is, what it does, and how I can, stop it from pivoting around the network and this sort of thing. So finding related malware so that you can figure out what previous work has been done will save an incident responder's time. So, these are both basically the same problem, but from two different angles. You've got like the emergency situation, then you have the malware researcher that has time to kind of figure out what's going on and not lazily, but at their own pace, look through the different pathways to other associations and other associated samples. So, there's a couple of related solution methods, so different methodologies for answering these questions and kind of solving some of these problems. And I'm going to start with there's kind of two different ways to think about this. So sample identification, that is the what is it that I'm looking at? What malware family is it? Potentially who is the adversary that wrote it, and this sort of thing. So determining the malware, identifying the malware family is one piece of this process. And then the other part is locating associated samples. So within a set of samples, which ones of this set, what subset of that set are related to the sample that I'm looking at right now. So there are many different methodologies for doing this. Also, this talk is by far not an exhaustive listing of the methods for doing this. I think we were having coffee on Monday, and someone mentioned a method that isn't in my talk. So there are many methods, and after this, I'd love to talk to you if you have anything that isn't in the talk and you want to tell me your methods for identifying other samples or identifying malware. I'd love to talk to you about it. So the most basic, simple, kind of dumb method is using antivirus scanner results. So you can't really use one antivirus scanner result. What you want to do is go to some place like VirusTotal or you guys Reversing Labs, where you have a lot of AV scanners, and you can scan a sample across basically all known AV scanners and get results back from all of them. But then you have another problem. So the first problem with that is you have shared signatures. And from an antivirus company's perspective, this is actually not a problem. This is only a problem from the researcher's perspective. This is actually a good thing. Like I am all for sharing information among companies and sharing information among researchers. So this is by far not a problem from the perspective of being altruistic. But this is a problem for a reader. So you have shared signatures. Many companies that will develop a signature for their particular scanner engine will share that, under a non-disclosure agreement with other companies. So you end up with nearly identical scanner results for one particular file from many different AV vendors. So this is an example of this. So that's the MD5 for the sample. You can go find it. It's on VirusTotal. The scanner results. So this is just a generic scanner result. But I picked this one out because it's both a generic scanner result, but it also is fairly specific. So that number is very unique across all of the scanner results. And this exactly the same scanner result is on AdAware, Aliac, Bitdefender, Emisoft, F-Secure, GData, and MicroWorld eScan. And you'll also, if you kind of look through AV scanner results a lot, I know that sounds boring, but I do that a lot. And you'll see these patterns emerge across the companies, and you kind of figure out who's sharing samples, and who's sharing signatures with each other. So that's a problem. And then another problem with the methodologies that AV companies use to produce their signatures is they take two different approaches. So you have the generic approach, and the generic approach is basically you want to write one signature that spans as many different malware families as you possibly can, because the goal of an AV company is to detect and block the malware. It's not necessarily to identify the malware. That is perhaps a secondary or a tertiary goal. So, excuse me. So you have your generic beer, which is the generic signature, and there's actually there is a financial reason for AV companies to produce signatures in this way, because it takes time, money, and people to go and research and figure out what the signature needs to be, and so it costs less for you to develop a generic signature that detects lots of stuff than it is to develop lots of specific signatures that detect specific malware families. So also, this is a little advertisement for my favorite beer company back in Washington, D.C. So this is DC Brow Corruption IPA. I highly recommend it when you're in town. So you have these two kind of diametrically opposed forces in they're financial forces, where you have the push to have a generic signature that doesn't tell you much, and then you also have researchers who want to have signatures that are fairly specific and identify something. So I want to call out a few vendors that have good results. Thumbs up to them. Thumbs up to any of you that might work for any of these companies. Good job. Not only do they have usable results, but they also have, each of them have varying qualities, some better than others, but they have, threat encyclopedias or threat analysis, databases or whatever that are all online, all are free. You can look up the scanner result in their threat database or their threat encyclopedia and get a little bit more information about what the thing is that you're looking at. So Microsoft is very, very, very good. I think I just spoke with some people in the other room, and this was the first one that they talked about, and I agree. Microsoft has very, 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 very good, very specific detections, but they don't detect much in the first place. So you have to actually detect the thing before you can actually get a result. So it doesn't detect much, but if it does detect it, it's very, very good. ESET, Kaspersky, Sophos have fairly specific scanner results. So what I want to show you is, and I have, so what you need to do is, once you've submitted a sample to a bank of AV scanners, you'll get back like a pile of data, and then you need to boil it. You need to boil that down into maybe one or two names that are basically commonalities across all of the scanner results. And so I'm gonna kind of walk you through this. So the first thing you'll notice is this is actually not. This isn't all of the AV scanners that were run against this sample, but excuse me. So what I've done is I've gone ahead and removed all of the generic ones, just because space on the slide, and the generic ones give me no information. So what you'll see here is, if you look carefully, if you think about the problem that I highlighted earlier, where you've got shared samples, if you're going to write an algorithm that pulls apart the AV scanner results and then gives you one scanner result, you need to correct for that problem of shared signatures. So what you'll see here first is obviously, sorry, I skipped a slide, but you need to remove clearly generic results. You have to also look for some of the sneaky ones that are basically generic by now. Zeus, Zbot, Zeusy, etc., like that. But what you'll see here, there's one commonality here. So these are all exactly the same signature. I'm going to go ahead and count that B one down there in the bottom as the same signature. So all of these basically are just one signature. So that's just one result. So you need to correct for that if you're going to write an algorithm to kind of boil down your results. There's another one here. So these two, so Avast, AVG, those are clearly a shared signature. So again, you have to correct for that one. And so moving down, I've boiled this down to two. So two possibilities here. These are clearly all different signatures from different companies. So ISBAR or SIMI, both of these are also by the way, these are fairly generic results, but I just wanted to demonstrate the process. But if you look here, those are pretty much the same. It's just the formatting of the scanner result is about the same. So I'm gonna collapse those two down and say that the result is mostly ISBAR and a bit of SIMI. So I have actually an algorithm for doing this that breaks it all apart and kind of finds the commonalities and corrects for shared samples. And I hope I'll be able to have time to put that up on my GitHub, but watch for it. It's github.com/utkanos. And so the next identification method is, so this is a fairly new service. In December of last year, I was at BotConf and they kind of did their announcement of Malpedia. So Malpedia is it's an incredibly good concept. It's a little bit sparse right now. It needs more information to be put into the system. But it's basically an identification system for taking a sample and then finding a malware family. So let me go to the next slide. So this is actually straight off of their website. So the primary goal of Malpedia is to provide a resource for rapid identification and actionable context when investigating malware, openness to curated contributions, shall ensure an accountable level of quality in order to foster a meaningful and reproducible research. So essentially what Malpedia is a collection of Yara signatures that have been written by trusted researchers. It's a closed community, so it's invite only. And once you're in, you basically should be contributing information, contributing samples, working on some of the Yara rules that are in there for identifying samples. So one of the things that it lets you do is basically upload a file and then have that file run against all of the Yara signatures that are available in Malpedia, and then potentially, if it matches one of those Yara rules, it'll give you a rule name, number of strings from that particular Yara rule that were matched, percent match, and then yes or no whether it matched or not. So. It has the potential to be a very, very good resource. And so, if you're proficient at writing Yara rules, if you've got some free time, I highly recommend trying to get into the community and contribute to it. It needs to have a few more Yara signatures in there, but it's a pretty good service right now. So I will plug my former employer. So there is a method that we have or had back at Threat Connect. So one of the so you can sign up for a free account at TC. I still love them; they're great. But there's a system that my team developed there. So it's actually very, 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 very simple. Totally simple. So basically, Threat Connect is a threat intelligence platform, so you can relate different indicators together. It's a bit graph theory-ish, and so This is actually a blog that we wrote, that my team wrote last year when we first deployed this particular source of information. And so what we're doing is basically pulling in all of the different blogs, reports, and anything that we can find that have indicators that are published in the blog, and then basically putting them all in one place, and then finding, letting you find relationships between indicators that are in those data sets. So this first one is actually a link to the blog. Go read about it after you sign up for an account or before. And then the knowledge base down here is just a little bit of a guide for how to get into the data and figure out, get it indexed properly and browse it and find data that you need. So this is a particular, there are a few dynamic DNS, there's not just a few, sorry, there are many dynamic DNS, host names. So this is just an example of dynamic DNS from hop2.org. I think that's a Dyn, I don't remember off the top of my head, but you can see you've gone from some indicator that you might have collected off of a PCAP or something like this, and then you want to find any of the reports or any blog postings that have been published about this, and then you can go here, kind of pivot to the blog post, and then go read the blog on that blog site. So this right here kind of solves that incident responders problem where your hair's on fire, you've got a malware sample, you don't know what it is, and you need to figure out what it is as quickly as possible. And then there's also the most basic identification method, Google it. So if you've got something, just start Googling it, and chances are you'll find something. Like you might find some result from hybrid analysis, or you might find something out there and also in a blog somewhere else. Can't hurt to Google it. And this, there's the requisite XKCD cartoon about how to become an IT expert, which is Google it, basically the, find a menu bar item, blah, blah, blah. And then this is the most important part. It's go to Google, type in the program name and a few words related to what you want to know. All right, so moving from the kind of simplistic methods there, I'm going to talk to you about some static analysis methods. So based on static analysis, different data points that you can get from doing static analysis, and then pivoting to different samples. So these are some of the most basic ones. You've got ssdeep. So ssdeep is a context-triggered piecewise hash. And in English, what that means is if you have a file, you can take a hash of that file, and you get a string of characters. And if you have a file that's just has some of the data changed in that file, you'll get a string of characters with just a few of those characters changed. So using the ssdeep algorithm, if you have two files and you have their ssdeep hashes, you can compare those two and see how different they are or how similar they are, and you can pick a threshold of how different or how similar you want them, how your threshold for saying something is or is not related. And then if you have a giant database of malware, you could submit one ssdeep for the sample that you are looking at, and then potentially you'll get back files that are at least structurally related to that particular file. There's a few points with ssdeep where it sucks. So ssdeep sucks because of packers. So if you're going to run ssdeep on a particular malware sample, make sure that it's unpacked. If you're running it on a packer, you're basically just taking the ssdeep of the packed malware, and you're going to find other related packed malware that's packed using a similar packer, and you're not necessarily going to catch the same malware family. Import hash. So import hash is calculated from the PE file's import table. So you take the import table and then you hash it, you come up with a string of characters, and then that string of characters can be compared to a database of other import hashes, and you can find files that have the same import hash. And again, import hash sucks in one particular situation. So import hash sucks for .NET. So if something is compiled with .NET, you put in the import hash and you're going to see thousands and thousands and thousands of other .NET import hash. And they are definitely not related to the thing that you're looking at. except for a few of them, and you'll never find them because they're going to be a needle in a haystack. File names are a bit boring, finding exactly the same file name, but what's exciting would be, or a little bit more exciting, still a little bit boring, is developing a regex. If you find that a particular malware family drops a copy of itself or drops a payload, and the payload name changes dynamically, there's the potential there of figuring out a regex for what that dynamically changed file name is, and then using that regex to look for related files. Now here's where stuff gets a little interesting. There's a few secret squirrel groups that share URL pattern regexes. If you want to come and ask me about that after the talk, we can chat. So there's basically the URL structure for payload download, and this is where the malware that's running on your machine reaches out to its the payload location, downloads a file, and then installs that payload on your machine. So that's a child of that particular layer of malware. So the URL structure of the download URL is more closely related to the vulnerability that was used in the CMS. So it's more related to whatever plugin they exploited to get into your WordPress site for your barbershop and upload the malware payload so that they can piggyback on your website. So it's not all that valuable for what I'm talking about, but I just wanted to kind of highlight that that's something that you can look at. So an example of this, so if you have 2016, if you've got like the WordPress theme 2016, 2015, 2014, 13, 12, they're all vulnerable to something. So you can write a regex that will kind of look for that particular pattern. I know this is this is actually kind of not as, this particular regex is not all that useful. I just wanted to demonstrate like the methodology for putting together a regex. So this one's actually quite easy to read. Now this is where it gets interesting. So the URL structure for C2 is where it gets into the structure of the C2 format is directly related to the malware family. So you'll see Pony. Pony has various file names for in the URL, lots of different URLs. So I'll give you an example of one that I found. So this was back in January. So I was working with a journalist who was under attack, and I was sent some of the samples from him, and I didn't. So there's actually, as you can see here, there's a UID. There is a UID in this URL, but I'm not going to show it because it actually has the victims. It's an encoded, it's an encoding of the victim's email address. So I'm not going to have that up on the board. But basically, you have the C2 URL, and then you've got a regex that can detect similar ones, and you can use this to find related C2 URLs. This one in particular, I think we all know who this one is. So this is a blog that I wrote right after I found this, and it's actually they were leveraging Blogspot, and basically it's basically the worst blog post ever because it's just like one forwarder to another place. So then, you've got a whole rabbit hole of EXIF metadata. So if you run a sample or if you run a document through EXIF, you get this massive, monstrous pile of data. Let me see if, yeah, awesome, it actually worked. All right, so up here, some of the really good ones are timestamp. So the compilation timestamp of the malware, this is very valuable. You can use this in a couple of interesting ways. If you know the time that a file was submitted to something like hybrid analysis or to VirusTotal or something like this, you can compare that time with the timestamp of the malware, and if they're both within a certain period of time, very fast, a very small amount of time, that means that this has probably been submitted by the adversary and they're testing the AV detections or something like this. So that's a valuable data point. You've got other stuff in here like an entry point, versions of the software or fake versions. Some of it is just, keyboard mash. But there's a plethora of data, and also language. So if you're interested, if it's something that isn't English, then that is an indicator that you can use in concert with other indicators to find relatedness among malware. So let me go back to here. And another way that you can find other malware is through code signing certificates. So it might be signed by a fake cert. It might be signed by a real or stolen cert. It might just look like it's signed. They've made it look like it's signed, but it's not actually signed. The signature is just broken. So it's signed-ish. An example of this, so this is actually fairly old. Some of you might recognize this immediately, DTOP tools. But this is a Desaruby APT signed malware sample. So this is actually a valid signature from DTOP tools in Korea. And so we found using that signature, we found a lot of other samples that use this same valid signature. So this is actually a related sample, which is Sacula, and so this is probably a fairly famous one. So this is one that my team found. This was during the Anthem hack a few years ago. I think many of you might know it's an insurance company in the United States that was hacked, and WellPoint is WE11 point is the fake domain that the adversary stood up for that particular operation that they had. So, we wrote a blog post about it. So please go check out the research. I'm not going to go too in depth into it because we've got about 20 minutes left. But moving on, so another good data point, sections, resources, import table, imports, exports, all of these various things can be used to find related samples. It's hit or miss. You have to, for some of these, like the sections, it's good to look for sections that have low entropy. If it has low entropy, chances are it isn't something that's encrypted, so you're not going to, you won't find something else that has the exact same hash. So just to give you a little primer here, so what we're talking about are different sections, different areas of data in a file, and what you want to do is take a hash of those particular sections or parts of the file, take a hash of them, and then take that hash and look through a database of hashes from that particular part of a PE file, and you potentially can find other files that are related to the one that you're looking at. All right, so sections specifically. So this is a section and a sample. It's just a random one that I found, but basically the MD5 down at the bottom is a sample that's related. I'm sorry, this is the MD5 of this particular relook section. And then resources, this is another way. So you've got this particular sample in the RT version, the SHA-256 of this is such, and so you can use that particular hash to go find samples that share the same resource. I know I don't normally talk about proprietary products and stuff like that in my talk, but VirusTotal has a really cool index called Similar To. I have no idea what is working under the hood. It is complete proprietary black magic, but it's fairly effective for finding other files. So if you have a subscription to VirusTotal, I highly recommend going and digging in and looking at this one. And then document metadata. I could probably spend an entire hour talk on leveraging document metadata to figure out for related malicious documents. But some of the highlights for that, you've got the author for documents for Word docs and Excel, etc. Timestamps are important, created timestamp, modified timestamp. Language can be important, and then in the land of PDFs, the equivalent of the author is the PDF producer. So all of these are very, very good indicators that things are related to each other. So moving on. So let's actually park all of the information that I just went over for static analysis, because we're going to come back to it when I get into like the machine learning part. But let's talk briefly, and I know this part is, I think everybody, if you work in malware analysis, you probably know a couple of these methods. This is very, very basic, so I'll kind of breeze through it. So you have mutexes, so a mutual exclusion. If you have, most computers now have concurrency, and so you can actually run different threads, or you can run things on different processors. And so because of that, a program needs to have a mutual exclusion so that two of them don't run at the same time. And so therefore, malware also needs to have a mutual exclusion or a mutex. And so sometimes that mutex that they use is unique to that particular malware family. And so that that is a way of finding other related samples. Of course, what registry keys it touches, whether it writes them, whether it reads them, modifies them, etc. That set of registry keys can be unique to a particular malware family. I know this part is very simple stuff, but now all the information that we just talked about that was from static analysis, I'm going to talk about how to leverage this. And by the way, this is not this isn't a method that I came up with. This is actually Seb Draven. If you are familiar, this is actually, so I highly recommend going and taking this this workshop from him. I took it at BotConf back in December. Fantastic. So it's about Python, using Python and machine learning to clusterize malware. And specifically, I like to reuse as much information as other people can provide. So, but I highly recommend going and everything you need is on GitHub. So please go look at his stuff. Also take his workshop if he's offering it again. But the basis of this is taking particular data points that you gather from static analysis and using them with machine learning algorithms like k-means and dbscan to basically clusterize the malware, and from a large malware set find clusters within that malware set. And so one of the things you'll notice here is that a lot of people think machine learning, I need a GPU. So you actually don't need a GPU for machine learning. It can help if you have a very, very large data set, but if you have a manageable data set and you want to figure out related clusters, you don't need a GPU. What you need is a glass of wine. So if you have a laptop such as this one right here, plus some sparse matrices. So that's one of the keys to using to getting away, basically getting away with machine learning on like a not so powerful machine, is to use sparse matrices. And so the basic for anyone that isn't a mathematician, the basics of a sparse matrix is if you've got a matrix of so many points, you have a lot of zeros. Typically there's a zero in many positions in that matrix, and so you're actually wasting a lot of resources processing that matrix because of those zeros. So there's a method of basically kind of collapsing the matrix down to a sparse matrix, which removes the zeros and makes it manageable for a less powerful computer to work with it. So I highly recommend going and checking out Seb Draven's class, his workshop. But moving on to another one, so this is actually the diamond model of intrusion analysis. So this is something that ThreatConnect, my former employer, highly, they basically built some of their system on this model. So rather than using malware, and by the way, so we had a really incredible discussion coming up with a diamond model for Star Wars. And by the way, you cannot believe how heated of an argument we had about like where certain points lie in the diamond model. But this basically helps you kind of understand the diamond model. So you have the adversary, you've got the victim. Capabilities are kind of like a special term for the malware sample itself. So a malicious document or a Trojan, that is under the auspices of capabilities. And then infrastructure, so this is all of the online infrastructure, email addresses, anything that's used to communicate with the capabilities. So, and then the bottom is the victim. So this is the target of the attack. And so the diamond model actually gives you two axes, and this is where things get fairly interesting. So the technical axis is where the capabilities communicate with the infrastructure, and then the socio-political axis is basically answering the question, why did this adversary attack this particular victim? And so, even if you don't have data in all of the corners of the diamond, you can actually, infer a bit of who did it, who done it, if you have a sum of the data on here. So if you've got a victim and you've got capabilities, you may be able to infer who the adversary is. So that's the basics of the diamond model. And I invite you to go read. So it's actually a scholarly paper. This is the URL for that, and all my slides are going to be available. I'll put them up on SlideShare. Hopefully this evening, maybe tomorrow. So don't worry about writing down all of the URLs. You'll have them. So. Another association method, and also I apologize, I don't have screenshots of this because this morning I was trying to connect to it and there were connection issues. I don't know if it's the ISP that I have here in Serbia, but I wasn't actually able to connect to Icewater. But Icewater is a free service where you can actually, and this is the URL for it. So Icewater uses, an algorithm for comparing two malicious files and finding clusters of them. And then you can also take a cluster and you can find its cluster neighbors. And so if you've got a cluster of maybe 10 files, you can find another cluster that's potentially like basically one step away from the cluster that you're looking at, or 2 steps away. So these related clusters may also be related to the malware cluster that you're looking at. So it's a really powerful system. I highly recommend it. There's a daily report of new files that have come in, and then there's a listing of the clusters. And there's some methods for finding interesting things. So if you've got a big cluster that has old files in it, the new files that have been added to that cluster may not actually be that interesting to you. But if you've got a cluster that's new of like 2 files or a cluster of 3 files, that's the gold. Those are the things that you want to go start reversing and dig into. And I apologize for not having a screenshot of it, but in the slides that I post on SlideShare, I'll definitely make sure to get some screenshots in there. And then, so this is actually a really very, very, very interesting method that I learned about, quite a few years ago. So 2014, I was in DerbyCon. And there's a gentleman there who's giving a talk about control flow graph analysis. The talk that he gave, so this is all the information about that. So it's the control flow graph based fire scanning. So DerbyCon 2014, the author's name is Douglas Goddard. And if you watch this video, if the camera were like this, you'd see my head. But I was right in the front row, right in front of him. But is a very fascinating methodology. I plan on kind of taking basically taking the process that he used and then applying it to PE files. So one of the problems, it's not really a problem, but he focused only on APK, so basically only on Android malware. And the reason for that is it was very easy to get the source code back from a Java APK, and then to take that and get a control flow graph was very easy. So I'd like to actually take that and kind of go to another level and look at the control flow graph analysis of PE files. And so actually, is Kirill here? Kirill, where are you? I changed this slide for you. Oh, and you're not even in here. All right. Well, he went to the Redair conference. He just got back, so this is actually a new slide. It was IDA, but I switched it for Redair. But it's basically showing you the same thing. So these are code blocks, and so these lines that connect the I want to go to this one. So these are code blocks, and so the lines that connect them are jump statements in assembly code. So if you've got a jump that creates a loop, that's one type of control flow. If you've got an if-then statement that jumps to two optional code blocks, and so basically, if you take the essential like quality of this. So this is actually called an adjacency list, and what you want to do is take the adjacency list and then basically display it as a matrix. So you have an adjacency matrix, and once you've got an adjacency matrix, you essentially have, as long as that matrix is based on non-library code. So you want to focus on code that was written by the adversary, not code that was written by Microsoft or written by some library that they got off of GitHub. So you don't want you want to exclude library code, but once you've excluded library code and you convert an adjacency list to an adjacency matrix, you now have the potential of a signature that can relate basically the coding methodology of the adversary, and you can find other files that are not necessarily, might not even be the same malware family, but were coded by the same person potentially. So that's a very interesting angle of comparing files and finding related files. And actually, one of the things I'm working on is converting this sort of methodology to PE and looking at PE files, because that's where all the malware is. There's a lot of stuff in APK, but there's a plethora in the land of Microsoft. So that's it. If you have any questions, I want to open the floor to questions. I think we've got a microphone. Questions?
Anyone?
Yes. Hope I can answer.
Well, at first, thanks for your talk. It was very interesting. My question is, what's your opinion on the reliability of these indicators when it comes to false flag operations? For example, we have seen the Marble framework from the Shadow Brokers release, or whatever you call it. How reliable is attribution in that way?
So, that's a really good question. So, what I would say is, if you are aiming to do false flag, and actually when this was back in 2016, we had a couple of naysayers that were throwing rocks at my research, and they were saying that, I can stand up C2 infrastructure that looks exactly like certain APT groups, and I was like, no, you can't. Nope. And the reason why is, yes, absolutely. If you look at one of these methods, that method by itself absolutely can be reproduced, absolutely can, fail. You could have, false flag operations, you could have false positives. But when you accumulate many pathways of not necessarily, I'm not going to go with the attribution, but pathways of associating files to previous files so that you make associations in that way, the more variety of associations you make, the stronger the the attribution or association gets. So any of them on its own is weak, but if you have a number of them together, and that's one of the really basic components of the diamond model, is that you don't just have one pathway to attribution, you have a couple of different pathways, even like the socioeconomic axis. Hope that answers your question. Questions? More questions? All right. Thank you. Thanks, everybody.
Thank you.
And if you want to chat about any of this stuff, I'd be happy to chat with you out there, or actually over there in the drinks and food room. So, thank you.